Everyone, so let's solve this integral. So what's so special about this problem? Well, inside the square root we have three terms, right? A full quadratic function. Now in the previous video we learned that we are gonna rewrite this function in a different way and then we are gonna solve it from there. Okay, so we use completing the square method to rewrite this function. So in case if you have missed that video, please go and watch that. Okay, after that come here. Alright, so let's rewrite this function. X square plus 6x plus 13. Coefficient of x is 6, so half of 6 is 3, so this is almost equal to x plus 3 square, but x plus 3 square is actually x square plus 6x plus 9, but you have 13 here, so you're off by 4, so you add a 4. Okay, alright, so let's rewrite the integral in new version using the new version of the function. So x plus 3 square plus 4. Alright, now let's proceed from here. What is the substitute here? Now is it sine, secant or tangent? Well, we have plus here, so it has something to do with tangent, right? And we know our a square is 4, so a is 2, so this is 2 tangent theta. Now the problem is, instead of x here you have x plus 3 square, so we usually have x square, right? Now how are you going to deal with that x plus 3 here? Well, instead of x we have x plus 3, right? X is the placeholder. Instead of that placeholder we have x plus 3. So instead of x, let's have x plus 3. So if you had the problem like this, x square plus 4 square root of x square plus 4, to integrate your substitution will be x is equal to 2 tangent theta because you have x here. But when you have x plus 3 square plus 4, right hand side is going to be the same, but the left hand side is x plus 3. Instead of x you have x plus 3. I hope you got my point. Okay, now let's do the usual trigonometric substitution from here. Okay, so now we can replace x plus 3 by 2 tangent theta. So let's do that. So 2 tangent theta square, right? If I replace it here, and don't forget the square root, plus 4. Oops, now we have to replace dx by d theta. So we have to differentiate this. Now here's my advice. To differentiate this, I will rewrite it. Okay, so I will take this 3 to the right hand side. So it will be 2 tangent theta minus 3, right? Now you can differentiate x with respect to theta, right? That is why I took that 3 to the other side. So clearly you can do that very clearly and easily. So it's straightforward from here to take the derivative. So derivative of x with respect to theta. So derivative of 2 tangent theta is 2 secant square theta. Derivative of negative 3 is 0, right? Derivative of a constant is 0. Okay, so then here dx is 2 secant square theta d theta. So we have all the details now. So let's replace it here. Instead of dx, I replace 2 secant square theta d theta. Alright, now let's simplify this square root. So if I square this, it is going to be 4 tangent square theta plus 4 square root 2 secant square theta d theta. Now we can factor 4 inside the square root, right? So it's going to be tangent square theta plus 1 square root of the whole thing. 2 secant square theta d theta does not change here. Now tangent square theta plus 1 is what? Secant square theta from the Pythagorean identity. So square root 4 secant square theta. Now 2 secant square theta d theta. Don't be in a hurry. Now we have to take the square root. So if you take the square root, you get 2 secant theta on the bottom and 2 secant square theta d theta here. Now what do you think? Well, secant cancel out, 1 secant, 2 cancel out. Well, that's good. So only thing we get is secant theta d theta. So we have to integrate secant theta. Now in this video I'm not going to go over how to integrate secant theta, but I will rather give you the integral, okay? Because I want to focus on the last part, how to rewrite the solution in terms of x, because that's tricky. So integral of secant theta is actually natural log secant theta plus tangent theta plus c. Alright, now you have to rewrite this in terms of x. What do we use? We use the substitute. What was our substitute? X plus 3 is equal to 2 tangent theta. Let me check whether I'm right. Yes. Okay. Now we want to replace tangent theta by x, secant theta by x terms, right? So what do you think? Well, tangent theta is x plus 3 over 2, right? So tangent theta is x plus 3 over 2, so that's straightforward. Okay. So secant theta is actually plus x plus 3 over 2. Now we just need to replace secant theta. What can we do? We have to use the triangle. So tangent theta, let's mark theta. Tangent theta is actually opposite over adjacent, right? So the opposite is x plus 3 here. Adjacent side is 2 here. So let's use the Pythagorean identity. So we want to find that c. So here x plus 3 square plus 2 square is equal to c square, right? Using Pythagorean theorem. So here c is actually the hypotenuse length is actually square root of x plus 3 square plus 2 square is 4, right? Okay, so that was easy. Now what is secant theta? Secant theta is actually 1 over cosine theta. So 1 over cosine theta means what? Adjacent side over hypotenuse. That means reciprocal of adjacent over hypotenuse is hypotenuse over adjacent. So what is hypotenuse here? What we already found. So hypotenuse length is square root x plus 3 square plus 4 over adjacent side is 2. So that's 2. So this is secant theta. So let's write the final solution, shall we? So natural log secant theta is square root x plus 3 square plus 4 over 2. Tangent theta is x plus 3 over 2 plus c. So this is the solution for the integral. Okay, so many things to digest, but do it slowly. I'll solve more problems in upcoming videos. Okay, all right, I'll see you there. Thank you very much. Bye bye.